Hello, in today's video, we're not going to be talking so much about this VORON switch wire here in front of me. We're going to be talking about what's on top of it. It's called the Enraged Rabbit Carrot Feeder. It's an open source multi-material unit. We're going to be taking a look at what a multi-material unit like the Enraged Rabbit Carrot Feeder is, what makes this one special, and how it works. So let's get started. So first things first, what is a multi-material unit? Well, with 3D printing, if you wish to print with multiple different filaments or materials during the same print, you need something to change the filament. Now there's different ways of doing this. You can use a multi-material unit or MMU, such as the Enraged Rabbit Carrot Feeder here, or the Prusa MMU for example. You can use a tool changer to change out tool heads, or you can use something like an IDEX system that has independent tool heads on the same axis, or even something like multiple independent extruders in a Bowden setup with something like a Y-splitter at the tool head. Now with 3D printing, there is no perfect solution to multi-material. Every setup has advantages and disadvantages. So depending on what kind of printer you already have, you may not be able to run certain setups, and depending on how you wish to accomplish multi-material, you're going to have to weigh the pros and cons of these different setups in choosing which one you want to go with. Now, one of the biggest downsides though to using a multi-material setup like the Enraged Rabbit Carrot Feeder though is time and purge. Anytime you do a filament swap, it's a multi-step process. You have to retract the filament out of the tool head, select a new filament, feed it down to the tool head, load the tool head, purge out the old filament till you get the new filament flowing, and then you can go resume the print. Now, if this is a 30-second to 1-minute process and you're printing something with 500 to 1,000 tool changes, that's going to add up to a lot of added time to your overall print time. And unfortunately with 3D printing, the longer the print is, the more chance something can go wrong. Also, purge itself is wasteful. If you're printing something like this bender here that uses 6 different colors and uses multiple colors per layer, you're going to end up with a purge block that is almost the same size as the print and many times much heavier than the print itself. And unfortunately, all this filament is now garbage. So with multi-material, you do have to understand that you are going to be generating quite a bit of waste when printing with multi-material units like this, and you're going to be adding a lot of print time to your prints. So the multi-material unit we're taking a look at today is the Enraged Rabbit Carrot Feeder. Now this is an open source design, and at the moment if you want one of these, you're going to have to build it yourself. Now there are some kits available for multiple different vendors. The kit that I used for building this one was provided to me from deepfriedhero.in, free of charge on the condition that I build it on stream and do a review of it. You can also self-source if you wish to source the parts yourself or purchase kits from AliExpress vendors. Now when it comes to actually building the Enraged Rabbit Carrot Feeder, it is configurable. You can build it in different ways, including controlling how many filaments it'll feed. Most commonly you see 4, 6, and 9 setups. This one is a 6 unit. However, I've seen as few as 2 setups, and I've seen up to 18 feeds. So if you want to control 18 different filaments being fed to your hot end, you can do that with the Enraged Rabbit Carrot Feeder. Now also when it comes to controlling the Enraged Rabbit Carrot Feeder, you do have some options available. The whole unit was designed with Klipper in mind, so you could take advantage of the fact that Klipper could run with multiple different controller boards on the same printer. So in my case here, I have the Easy board hooked up to my Enraged Rabbit Carrot Feeder. That is a board that's designed specifically for the Enraged Rabbit Carrot Feeder. However, you could use something like an old SKR or even a Ramps if you wanted to run one of these. Alternatively, if your 3D printer has a controller board that has enough available drivers and hookups for end stops and sensors, you could actually just plug it into your existing controller board if there's enough room available. So you can go about building these and controlling these in a few different ways to suit your particular needs. Now, when it came to building this one in particular, we did do it over several streams, and make sure you're subscribed to the channel so you don't miss out on any of my streams. And I will say the overall build experience is pretty good. During my streams, the documentation was being worked on, so if you happen to follow any of the streams to use that as a build guide, I'd highly recommend actually following the manual as it is currently. There has been a lot of updates to the manual since my original streams building this, so I'd recommend following the manual itself when it comes to building one of these, and just use those streams as a reference if you need it. But the actual build itself, while it did take several streams, isn't really complicated. You just have to make sure you're following along, and there's a lot of steps to it, especially when it comes to doing your initial configuration and tuning of the Enraged Rabbit Carrot Feeder. There's a lot of settings and parameters that you have to have dialed in pretty accurately for this to run as optimally as possible. Now, since that original build, I did change out a few things. The first one is the kit came with a NEMA 14 motor, which is the standard. For some reason, I was having issues with torque with that motor. I was losing steps when feeding filament to the tool head at the speeds I wanted to feed. I shouldn't have had issues. The motor should have been fine, but I did swap out to a NEMA 17 motor and I've had no issues since then. Something could have happened during the build and there might be a little too much friction on the feed gear somewhere in the system. I'm not 100% sure, but since switching to this NEMA 17 motor, that issue hasn't arisen. On the filament feeder cartridges, there's a top hat that actually floats using a repelling magnet. It works quite well actually, but there's an adjustable shim piece that determines how much preload is on those drive gears. Originally I had too much and I ended up cracking the servo arm that actually pushes the gears together for controlling feed. So I've had to swap out a few parts that I damaged from having incorrect settings while running this originally. Since tuning things up and spending more time ensuring everything was proper, those issues haven't arisen again. So we'll chalk up the issues that have arisen, mostly due to user error first time using this. And again, it's printed parts, so if you break one, just print another. So how does the Enraged Rabbit Carrot Feeder work? It actually works quite well once dialed in, and it's actually pretty smart. So when it does mess up, you can fix it relatively easily. So we'll start at the top here. You have the main body of the Enraged Rabbit Carrot Feeder itself. It can feed as many filaments as you built it for. So in our case, again, it's a 6-unit feeder here. And you have this tool head that moves along, and this selects which filament it's going to feed from. So it'll move across to whatever filament it is going to load, and there's a servo built into it. And when it activates that servo, it pushes a floating top hat down that pushes the two gears together. Now for the drive of this, it actually uses Bondtech dual drive gears to feed filament down to the tool head. So when it selects the filament, it closes those drive gears together, and then it'll feed filament through a gate all the way down to the tool head. Now, as it passes through the gate, this is where the first sensor is. There's actually an encoder in there, and it's not some fancy off-the-shelf thing. It uses a single Bondtech gear and a sensor to read the teeth as it spins. Now, it's not the most accurate encoder, let's be honest here. You're not gonna put it on a servo and a Makino. However, for measuring filament over a Bowden tube length, it's perfectly sufficient. And it's really great to have that encoder there because it measures the filament as it feeds to the tool head. So let's say, for example, your spool runs out of filament. It'll detect that, hey, I didn't feed enough. Or there's a jam in the spool itself. The filament got twisted somehow and it's no longer feeding, it's stopped moving. It'll detect, hey, I was supposed to feed 450 millimeters of filament. I fed 300. I tried feeding the remaining 150 because it'll do that. If it detects that it didn't feed all of it, it'll try and compensate because, hey, maybe it just got stuck for a second. It'll try and correct it. So, hey, I tried to feed 150 now, nothing fed, it's not moving. It'll park your tool head and it'll give you a warning in the console on Klipper saying, hey, something's gone wrong, come take a look. So you can go down, you can see, it'll see where it errored out on the G code, and then you go, oh, hey, it didn't feed tool 2. You can correct that issue, you can refeed to tool 2, and then you can just hit resume, and the print will continue off where it left off. Now, after feeding the filament down to the tool head, it'll stop just above the extruder itself, and what will happen is both the extruder and the Enraged Rabbit feeder gear itself will feed filament past the extruder till it hits another sensor just above the hotend. Now when this sensor trips, it lets it know that, hey, filament has been successfully fed into the tool head. It's ready to feed into your hotend, so it'll disengage the Enraged Rabbit Carrot Feeder. So the servo on the arm will come up, and that way the Enraged Rabbit Carrot Feeder is no longer controlling filament anymore. It's all at the tool head. Your extruder down there takes over and you print at that point. So having that tool head sensor is critical for the operation of the Enraged Rabbit Carrot Feeder. You can run one of these on pretty much any printer that is running Klipper, and somebody has ported the macros over to RepRap firmware as well, so I'll have links for both of those in the description. But if you do not have that sensor in the tool head, what happens is you're not going to have that extra redundancy. You can run it without that sensor. You're going to have to adjust some macros so that it's no longer looking for that sensor. But if you have some issue where the filament doesn't feed into the tool head, it won't know that. So you really want to run a tool head that has that sensor built into it. Now, the stock configuration for the Enraged Rabbit Carrot Feeder is based on a VORON. So the afterburner tool head, along with a lot of the common setups for the afterburner with different extruders, are supported. So check the GitHub to see if it is supported. If you're trying to install this on a printer that doesn't use the afterburner tool head, you may have to design something that has a sensor between your extruder and your hot end for filament detection, or you'll have to run without one and just lose that extra redundancy that's built into the system. Now, when it comes to retracting filament out of the tool head, it's pretty much the opposite process. The filament will retract up till it's past the sensor and the tool head, then both the extruder and the Enraged Rabbit Carrot Feeder will pull it up until it's above the extruder, and then it's just the Enraged Rabbit Carrot Feeder pulling it out of the Bowden tube and out. And what actually happens is once it passes the encoder, and again, the encoder is checking to make sure that it doesn't jam on the way out as well. When it retracts into the tool cartridge itself, as the feed selector moves away, a magnet moves with it and it drops a gate. So what'll happen is that way, if the filament, you have your Enraged Rabbit Carrot Feeder on an angle, the filament won't accidentally fall out at that point. So it keeps it contained in the unit. So that's the basics of how the whole Enraged Rabbit Carrot Feeder system operates. And now I'll go through some things I liked about it and some things I didn't like about it and some issues I ran into and some successes. Now, most of the issues that I ran into are user-related issues. My biggest issue, and the reason that my prints have paused the most, has to do with my feeding setup. Now, unfortunately, I am pretty space limited. So due to that, I'm feeding directly from a rep box that's pretty much right above this printer. What that means is excess filament, when it does a retraction during a filament change, just kind of chills back here. It's just hanging in the air. Most of the time, that's not really an issue, but every now and then some filament will jostle during a feed, for example, when it's pulling the filament tight, and it'll cause filament to just kind of back out a little bit out of the Enraged Rabbit Carrot Feeder. Unfortunately, when that happens, when it goes to feed that filament, it can't grab it. So it pauses it because it detects that it's not feeding correctly. I have to come down here, refeed the filament in, and resume the print. So that's really an issue related to my personal setup due to space limitations. I know those that are running the Enraged Rabbit Carrot Feeder with a proper spooling setup, that's not an issue that happens to them. I did have a servo die with this, unfortunately. My kit was one of the first ones sent out, and the model of servo that shipped with my kit was different than the ones that ship with it now. So I swapped over to the current servo that comes with the kit, and I haven't had any issues since. Most of the issues that I've had with this setup are pretty much related to just not tuning it properly at first. The manual was being worked on when I originally did the build, so the first few prints had some issues, and they weren't major issues, but for a multi-material unit, if something goes wrong, usually you can't correct it once it's past that point. So it did take a few prints to eventually work out what settings I needed to run to ensure that things were feeding properly. Things like speeds and feeds feeding down from the Enraged Rabbit Carrot Feeder to the tool head itself, how much retraction it needed past the feed selector cartridge, where the park position of the filament is in the Enraged Rabbit Carrot Feeder itself. A big part of using a multi-material setup such as this is you need to form the tip of the filament as you retract it out. If you retract filament and you have a long stringy bit hanging off the end, it can jam up the system either when it's doing a tool change or when it tries to feed back in. So you need to spend some time ensuring that your settings for how everything operates here are dialed in to make sure that you are getting successful prints off here. And when I show the prints that I've gotten off here, I'll point out what caused the issues that you see in the prints that do have issues in them. Now, midway through testing this, I did actually change out some hardware on the machine. Originally, I had an afterburner tool head with a Dragonfly hot end. I swapped that out for a stealth burner cooling solution. So now I have the 5015 fan versus the 4020 because, with PLA, more is better with air. And then I swapped to a Revo 6 hot end. And that actually led to a very pleasant surprise. With the Revo, and I'm gonna chalk this up to the fact that the heat break and the nozzle is all one assembly and it's a very smooth interior finish. Any issue that I was having related to the tool head itself pretty much disappeared. Every now and then I would under extrude a layer with the Dragonfly. I'm going to chalk that up to the filament kind of snagging at some point during the feed after it got past the sensor. But once switching over to the Revo, that issue that would happen occasionally pretty much disappeared. And since putting a Revo in here, I haven't had any issues at the tool head itself. Also on the plus side, the retraction bulb, so how clean the filament is when it does the retraction, without me changing any settings, pretty much were perfect with the Revo. Again, I'm going to chalk that up to the way the Revo is designed and how clean of a heat break it is in there from going from the cold side to the hot side. Now, another downside to this Enraged Rabbit Carrot Feeder is the fact that I don't actually print a lot of multi-material prints. This whole setup is designed for doing multi-material prints. So if you don't print a lot of multi-material, this isn't really a setup for you. However, the way I've been using it lately, I actually really like, and that is using it because I'm lazy. Right now in my rep box that feeds this, I have 6 spools of my most commonly used filaments for PLA loaded. And now whenever I want to print anything in PLA, I don't have to come downstairs and change the spool of filament that's loaded in my machine. So instead of using it to print multi-material prints, I'm using it to print single material prints, but saving me from traveling downstairs to change spools of filament. So if you just want to build one of these, hook it up to a few rep boxes on the wall and just let it take care of picking filament for you instead of having to do filament swaps on your machine, that's another valid reason to get one of these. So enough talking about this, let's take a look at how the prints that came off the Enraged Rabbit Carrot Feeder turned out. Now, be aware that the print quality is pretty much going to be determined by your printer settings. So if you put the Enraged Rabbit Carrot Feeder on a printer that doesn't have a good slicer profile and isn't tuned properly, the prints themselves, you're at the mercy of the printer. The Enraged Rabbit Carrot Feeder just handles filament swaps. Okay, so let's take some time now and I'll go over some prints that I've done with the Enraged Rabbit Carrot Feeder, and I'll point out any flaws and what caused those flaws. So I'll go through them in roughly the order that I printed them. So this, I guess you would say water dragon here, was one of my first successful full prints with the Enraged Rabbit Carrot Feeder. And you can see the issue with the under extruded layers on this print. I'm not 100% sure what was causing the issue, but that under extruded layer there, you could see on the fin, that issue stopped showing itself when I swapped over to the Revo hotend. Now next up we have this Patrick Star here who's looking a little surprised, and you can see a little bit of under extrusion in locations, but the most noticeable thing is the band of pink through his pants. And the reason for that is I had a failure to feed the filament, and when I resolved the issue, I accidentally loaded the wrong filament. So it was supposed to be printing green, it printed pink instead. And that's why he has that stripe there through his pants. So if you do have to resolve an issue with the Enraged Rabbit Carrot Feeder, make sure you check your G-code in the console and you load the filament that it was supposed to be loading, so you don't have that issue present itself. And then we have this happy little owl, which other than one under extruded layer of white, came out near perfect. Look how happy this little guy is. And then of course we have Bender here, and unfortunately he shows those under extruded layer issues. Again, I wasn't 100% sure what was causing the issue. I was playing with settings still, trying to rectify it. But again, when swapping to the Revo, that issue pretty much went away. So I wasn't 100% sure what was causing it, but it may have been hot end related. Also, you can see near the top of Bender, there is a layer shift. If your purge tower settings are not correct, you can have an issue where you'll develop a bump on the purge tower because you're over extruding after swapping in a new filament. And I believe what happened is my tool head actually got hung up on that bump, and that caused the layer shift there. Also, another issue that you can see with the Bender here, and it's really noticeable in the teeth, is the print itself isn't actually that clean in the corners. The reason for that is the way I had my slicer configured, it was actually overriding my pressure advance value, and I was running without pressure advance for a lot of these early prints. So again, make sure you take the time to go through the manual and ensure you're setting the right settings in your slicer and your firmware to ensure that you don't have issues while printing. And around this point is when I swapped in the Revo into the tool head, and this is when I started getting repeatable quality prints out of the Enraged Rabbit Carrot Feeder, as my slicer settings and firmware settings were now tuned and near dialed in. Now, even though you may think you finally dialed in all your settings and everything is good to go, you'll still come across things that will require adjustments. So even though I got my machine to the point where it was reliable and I was getting successful print after successful print, stuff would still come up. So for example, This Aztec warrior here, the gold fringe on his helmet. I had lowered the amount of purge I was running to try and speed up overall print time, and it led to this contaminated gold fringe. So you can see the purple filament had stained it. So you're always gonna have to tweak and adjust stuff with an MMU to get the best quality out of it. So at the end of the day, yes, there is a learning curve to using a multi-material unit such as this, especially an open source one that you're pretty much going to have to build and set up yourself. Once you get the machine up and running, it's an excellent piece of kit. Once I got everything tuned and set up properly and all the little bugs worked out, again, you are building it yourself. It's been reliable, and while I don't do a lot of multi-material printing myself, I tend to print a lot of practical things. Oh geez, and a lot of VORON parts. I am looking forward to using it in the future, and I do have some project ideas that will involve this. So make sure you're following the channel so you don't miss out on that. So I hope you enjoyed today's video. As always, if you do have any questions, make sure you ask them in the comments below. If you wish to build yourself an Enraged Rabbit Carrot Feeder, I'll have all the appropriate links in the description. If you want to help support the channel, the content I create, and the things I do, I'll also have links in the description for that as well. On your way out, make sure you like that smash button, and as always, I hope you have yourself a great day. Thank you.